project, I chose to do bridges. There are many types of bridges, but I chose to research the 5 common ones: the arch bridge, the beam bridge, the suspension bridge, the cable stay bridge, and the truss bridge. The arch bridge. Many of you have probably seen or at least heard of this before. What is an arch bridge? Basically, an arch bridge is a bridge shaped like an arch. It works by transferring the weight of the bridge and its load, which is the weight of the objects crossing the bridge, along the curve of the arch to the supports on each end. Some of its strengths are that no part of the bridge takes on too much pressure, and it is very durable because it gets stronger as it works due to compression. Some of its weaknesses are that it is not only costly to build, but takes time to build and requires extra maintenance. The beam bridge. This is also very common, like the bridges you see on highways. What is a beam bridge? Basically, a beam bridge is a bridge that has a strong horizontal structure that rests on 2 end supports called piers and carries traffic by acting as a beam. It works by transferring the weight of the beam and its load to the piers, which compress vertically into the foundation. Some of its strengths are that it is affordable, can be placed almost anywhere, is quick to build, and has multiple designs. Some of its weaknesses are that there are span limitations unless you interconnect multiple beam bridges, it is susceptible to sagging, and it weakens with age. The suspension bridge. In my opinion, I think these bridges are the nicest to look at. What is a suspension bridge? Basically, it is a bridge in which the weight of the deck is supported by vertical cables suspended from larger cables that run between the towers. Suspension bridges work by distributing the weight of the deck between the towers, which compress vertically into the ground. Some of its strengths are that it can span long distances, can be built high, so ships can go under it. It is flexible to withstand natural disasters. It has simple construction, which is cost effective, and, like I said before, it is pretty to look at. Some of its weaknesses are you might have to do a lot of foundation work if the ground is too soft, and because it is flexible, it might be temporarily closed if it is moving too much. Also, if there is too much heavy weight on it at any given point, it might struggle to hold it. Here are the cable stay bridge. This bridge is similar to the suspension bridge. The difference is it has diagonal cables rather than vertical cables. Also, it only needs 1 tower to anchor it, rather than 2 or more like the suspension. The cable stay bridge works by transferring the load of the bridge to the tower. See the picture of me with the ribbons? That's me pretending to be a cable stay bridge. If I hold out my arms without any ribbons, all the weight is in my arms. But with the ribbons, which are like cables, the weight is transferred to my head, which acts like the tower. Some of its strengths are that it has greater stiffness than the suspension bridges, so flexibility is reduced. It is cost effective and takes less time to construct. Some of its weaknesses are that it has limited span, higher labor costs for maintenance, and of all the bridges, it is the most challenging to inspect and repair. Lastly, the truss bridge. What is a truss bridge? It is a bridge that uses a series of triangles known as trusses. The truss bridges work by distributing the load to the trusses, giving it huge load-bearing capacity. Some of its strengths are that it is extremely strong, can withstand extreme conditions, and can be built on rough, difficult terrain. That is why you see a lot of truss bridges for trains around the country. Some of its weaknesses are it has high levels of ongoing maintenance, it is a difficult design, so it is harder to build. Also, it is very heavy since it uses so much materials, so it needs extra support beams. In addition to my bridge research, I also used a bridge builder simulation to design bridges that can sustain a truck's weight under various scenarios. I had to do the math to calculate the best possible construction model to stay within the budget. For the bridge simulation, I had to first identify a plan for building the bridges. Then I explained why my bridge design failed before it was successful. Lastly, I explained how simulations can help with the engineering design process and the lessons I learned from it. In designing my first bridge, I had to consider many factors. At first, I chose to do a beam bridge because it would save more money, costing only $2,000, leaving me with $8,000 still in the budget. This ended up being a failure bridge. The top picture with the orange beam bridge was my initial bridge design. As you can see in the bottom picture, the bridge did not hold and the truck fell through. Since the first bridge failed, I adjusted my design to fix the weak points. The action taken to correct this failure was to add supports in the center that was anchored to the land on both sides, as can be seen in the picture on the right. This turned the attempted beam bridge into a basic truss bridge that allowed the truck to pass safely. Even though I only discussed one bridge design in detail, I actually went through all 11 levels of the bridge builder simulation, as shown in the pictures here. Most of my designs were either beam bridges or truss bridges, as they seem most sturdy for truck traffic. Also, I couldn't come up with a successful suspension or cable stay design for the simulation. All the bridge levels were within budget. Depending on the terrain, I had a budget of $10,000 to $50,000 to design my bridge. In summary, some of the lessons I learned from and that is my GT project on bridges. Any questions?